Hello students, in this video we'll discuss PYQs related to difference equations. For all other topics, please check out the description. The first question from JAM 2021, question number 45. Consider the first order difference equation xn is equal to n plus 1 by n xn minus 1, where n is equal to 1, 2, 3 and so on. If x0 is equal to 2, then x100 minus x50 equals what? You have to find the answer in integer. So what we'll be doing here, we'll start by putting different values of n in this relation. So if you are putting n equal to 1, there you will be getting x1 is equal to 2 by 1 x0. That means 2x0. If you put n equal to 2, you will be getting x2 is equal to 3 by 2 x1, and from the previous relation we know x1 equal to 2x0, that means x2 is equal to 3 by 2 2x0, so 3x0. Similarly, for n equal to 3, we'll be getting x3 is equal to 4/3 x2, and from the previous relation, if we substitute x2 is equal to 3x0, we'll be getting 4x0. So if we keep proceeding like this, we'll be getting xn is equal to n plus 1 x0, and it is given that x0 is equal to 2, so x of n is equal to n plus 1 times 2. So in place of n, if you put n50, then you will be getting x50 is equal to 2 into 51. If you put n is equal to 100, then you will be getting x100 is equal to twice 101. Therefore, x100 minus x50 is equal to twice 101 minus 51, that means twice 50 is equal to 100. Therefore, x50 minus x100 equals 100. Next question from JAM 2022, question number 16. Let a second order difference equation be yn plus 2 plus 4yn is equal to 4yn plus 1, where n is equal to 2, 3, 4 and so on. Initial conditions are given, y0 equal to 1 and y1 is equal to 4. Then the general solution is which of the following? Option A, nth term is 1 plus n squared times 2 to the power n. Option B, nth term is 1 plus n 2 to the power n. Option C, 1 plus 1 upon n times 2 to the power n is the nth term, and finally nth term is n squared plus n plus 1 times 2 to the power n. So we have to decide which of the following four options is correct. So at this stage, we'll briefly recall one thing, that whenever you have a second order linear difference equation of this form, yn plus 2 plus a yn plus 1 plus b yn is equal to 0, then to get the general solution of it, first of all, we'll form the corresponding auxiliary equation, where we'll replace yn plus 2 with a square, yn plus 1 with r, and yn with 1. So we'll be getting the auxiliary equation r square plus ar plus b is equal to 0. So definitely it will have two roots. Now those two roots have three possibilities. First, they are real and distinct. Second, they are real and equal. And finally, they are complex roots. So when they are real and distinct, in that case, the nth term will be c1 r1 to the power n plus c2 r2 to the power n, where c1, c2 are some constants. When they have equal roots, then the nth term will be c1 plus c2n times r to the power n, and when r1, r2 are complex roots, then yn is equal to c1 cos n theta plus c2 sine n theta. So now here the given second order difference equation is this. So first of all, we require to form the corresponding auxiliary equation. So what will be the auxiliary equation? R square plus 4 is equal to 4r. That means r square minus 4r plus 4 is equal to 0. Now what are the roots of the equation? Note carefully, this is none other than r minus 2 square. That means r has two roots, 2 and 2. That means they are equal and real. So the solution will be of the form yn is equal to c1 plus c2n times r to the power n. So let us write this. What is r here? R is 2. So let us substitute it here, 2 to the power n. So that is the general solution. We now have to identify c1 and c2 from the given initial condition y0 equal to 1 and y1 is equal to 4. So when you are considering y0, that means you are simply putting n to be 0. So if you are putting n to be 0, you will be getting c1 plus c2 times 0, that means 0, times 2 to the power 0. Now what is y0 here? y0 is 1. So we are having 1 is equal to c1 times 2 to the power 0 means 1. So c1 is equal to 1. So let us now put it here. So if we put it here, we'll be getting yn is equal to 1 plus c2n times 2 to the power n. And now to use the second initial condition y1 is equal to 4, we require to put n is equal to 1. So if you are putting n equal to 1, here you will be getting y1 is equal to 1 plus c2 times 2. That means y1 is 4, so 4 is equal to 1 plus c2 times 2, that means 2 plus 2 c2, that means c2 is equal to 1 as well. So when you are putting the value of c1 equal to 1, c2 equal to 1 in this relation, you will be getting it as yn is equal to 1 plus n times 2 to the power n. So that is the general solution. So option B is correct.